Hi, this one will be about I2c. I will try to make it as simple as I can. So first we will start with this board that is on sale on eBay and other location on the internet and is used for Arduino, for example Arduino LCD. So what it is doing, actually it is converting the I2c into control of 8 bits and using this message in order to control LCD and other stuff. So first I will open the datasheet and I will do some explanation about this chip and about I2c. So this is, as I said, 8-bit I/O expander for I2c bus. So I2c is basically a bus that is using 2 wires only, but 2 wires is not very accurate to say because you will always also need the ground and also the VCC. So we can say that we must use the 4 wires because we need to get let's say voltage according to a specific point, and you can't leave the wires without reference voltage. So this protocol we can say is using 4 wires, but the basic wires are SDA and SCL. SDA is a dual direction control, meaning that it is bidirectional, and SCL is the clock of the I2c. Now the clock can be from a few kilohertz till a few megahertz. This depends on the chip that you are working with, and you need to read the datasheet in order to know what is the fastest way to drive the I2c. Now in this section we can see how this chips is built. So let's now ignore the interrupt and just look at the SDA and SCL, which is the interface of the I2c. We also have additional 3 wires that are called A0, A1 and A2, and we will talk about it in a few seconds, but basically this is the address of this chip, and we need it because, for example, if you will have few chips that are connected to the same line, because I2c can control up to 127 chips or units, so we will want to each one to know when we are activating the chip, and all the chips will be listening, and just the one that is in the same address will react according to the data that we will send. Now here we have the 8-bit ports, meaning it's like 8 binary ports. In each port we can see that it is bidirectional, so we can write value, let's say 0 or 1 or 0 volt or 5 volt, and we can also read if we would like to know what is the voltage in this wire. So the most important thing to understand is that the master on this bus have to supply the clock. The clock is not bidirectional. The clock is only from the master to the slave. And the SDA will be bidirectional, meaning the master can write and then will wait to read. Okay? So to make it as simple as we can, We will now look at a few timing diagrams in order to understand. So I2c protocol have a start condition, which is the start bit. The start bit is going from 5 volt to 0. This is the start bit. After the start bit, we will have the address that we want to read or write, and then we have a stop condition, which is going from 0 back to 5 volts. And the chip that is connected to the master will answer if he got the reading. So we have acknowledge from the slave, and the acknowledge will be that the slave now will take the SDA line and then we'll do a pull down back to ground. So what we can see here is that we have here the address. So by the way, we can now know what is the address of this slave, which is this chip. So the address, 4 bits, the MSB bits are fixed and cannot be changed, and the A2, A1, A0 can be changed by wiring them to VCC or to ground. So where do we do it, if you ask me? So this is simple. We will do it here in the chip. Now in this example, they tied all the pin to 0. So the address in this case, let's go back and see what is the address. So the address will start with this is 4, okay, and then we will have okay, let's see how it is written, because okay, one more explanation. The last bit or the LSB can be 0 or 1. If it is 0, so it will be write, meaning we are writing data to the slave, and if it is 1, we are reading data back to the master. So by the LSB bit in I2c, you always control if you are reading or writing. So now we know that we have in this chip, we have 8 different addresses. How can I know this? Because I have 3 different bits that are controlled by the pins of the chip. If I pull them down, it will be 0, and if they will be tied to VCC, they will be 1. So now if we will go back, there should be some address. Okay, so these are the available addresses of the chip. So we can see here that if it is LLL, meaning all the pins will be tied to ground, so the address will be 41 hexadecimal. How can I know that it is 41? Let's go back and see. So I am going back, where it was, just a second, here. Okay, so if we will split and we will go and look just at the 4 MSB bit, we will see this is 1, 2, 4, so this is 4, and then we have 0, 0, 0. Okay, so it will be 4, and all 4 and all other will be 0 in order to write, and for 1 will be to read. So let's see that it is same as we see in the table. So for 1 is to read, and for 0 is to write. And by this we can know all the other additional addresses that we have in this chip. So if it is all high, so it will be 4 and then F in order to read, and 4E in order to write. Later on, we can see how we are reading or writing. So basically what we need to supply is the correct address to the chip, and then if we are writing, so each bit will be the corresponding bit that we want to write. So where is P7 and where is P0? I don't know. We need to go back to the chip app and see how it is connected. So we can see that P7 is the MSB, okay, and we can find the pin of the chip, okay, pin number 20, and P0 is the LSB. So now we can know how to read and to write. So now I will build a circuit with Arduino, and I will drive a LED by using the Arduino library for I2c, and then we will test and see that we can light the LED and turn it on and turn it off. So how do I know if I turn the light on or off? So this will be depends if I'm connecting the LED with resistor to VCC, then the light on will be 0, or I will connect the LED from resistor to LED and GND, so it will be by one logic, it will light the LED. Okay, so I will now build a circuit and test it, and we will see that we are able in the control of the LED using this message. So basically very simple. We also have, I will explain about 1 minute about the circuit. So we don't have to get into the circuit, but we can see that we have flip-flop and again another flip-flop, which means that if we are writing something out, it will be constant till we will do a rewrite again, meaning that this chip have for each bit a memory that after I'm doing an operation of writing 1, it will be fixed 1 till I will write 0. Power on reset doesn't matter. I don't want to get into too much details, but we can see that we have here MOSFET, and this is the output, and we have here some protection, the diode protection, that we will not connect a voltage above VCC, so this diode will protect the chip, or we will connect voltage below GND, and then this diode will protect the input of the chip. We have here the MOSFET, which are N channel and P channel. This is like a NOT gate. So if this is a NOT gate, we have another NOT gate. So NOT gate and NOT gate are canceling each other, meaning if I'm writing 1, I will get 1 to the output. If I'm driving 0, so NOT and NOT again will be 0 to the output. The read pulse is used to read the data back to the chip. So okay, I don't want to go into too much details, but pretty simple, and this is all we need to do, and we will test it and check that the circuit is behaving like I'm expecting. So thank you very much, and bye bye.